In this video, we're going to do a bit more of stoichiometry practice where we will be working with a chemical equation. And I'm calling this one stoichiometry practice example set number 2 to distinguish it from the first video and other videos I'll be making. So first up, this says, many statues are made of marble, which is the same thing as calcium carbonate. Acid rain contains sulfuric acid, which reacts with marble according to the following equation. So we're given this equation. It says CaCO3 solid, that's our marble, plus H2SO4, that's the sulfuric acid, and it creates CO2, H2O, and CaSO4, and that's calcium sulfate. So first up, it says, is this reaction balanced? So let's check it. I like to offer this strategy where we kind of examine all of our elements. So we got calcium, carbon, oxygen, hydrogen, and sulfur, and we'll just examine both sides and see how many of each element we have. So like calcium, for example, we have one on the left and one on the right. Carbon, one on the left and one on the right from the CO2. Oxygen, so on the left we have 3 here and 4 there, so that makes a total of 7. And then we've got 2, 3, that brings it up to 7 there. And then hydrogen, we've got 2 from the sulfuric acid and 2 on the right side for water. And then sulfur, we have 1 on each side. So actually, yes, it is balanced. It's already balanced, so that's nice. All right, next question. It says, how many moles of calcium carbonate will be consumed? So consumed kind of like reacted, if 5.0 moles of sulfuric acid react with the statue. All right, so we're going to start off with what was given, 5.0 moles of sulfuric acid. And again, the sulfuric acid is the H2SO4. And then our general strategy, since they gave us moles and they're asking for moles, all we really need to do is go from moles of substance A to moles of substance B. So we only need the one conversion. And since it's a 1-to-1 mole ratio, so for every 1 mole of H2SO4 that reacts, we also need 1 mole of calcium carbonate. So where'd I get those ones from? So in the balanced reaction, if there's no number written in front, it's implied that there's a 1 there. And this is saying that for every 1 mole of calcium carbonate that reacts, 1 mole of sulfuric acid is also going to react. And then we make 1 mole of CO2, 1 mole of H2O, and 1 mole of calcium sulfate. And just to pay attention to our units, so moles of sulfuric acid is going to cancel. So we just get 5.0 moles of calcium carbonate. That's pretty messy. I like to be perfect about that. So calcium carbonate, much better. Okay, next up, it says how many liters of carbon dioxide gas are produced when 12 grams of calcium carbonate react at STP. Okay, so they got this STP thing and they're asking for liters instead of moles or grams. So the key idea is that for a gas at STP, and STP stands for standard temperature and pressure, which standard temperature and pressure includes 0 degrees C and 1.0 atmospheres. That is the definition of standard temperature and pressure. But when we have a gas at STP, 1 mole of the gas will occupy a volume of 22.4 liters. So that's the trick we're going to use. That's the conversion we're going to use in this one. So our strategy is grams of substance A to moles of substance A to moles of substance B to liters of substance B. So we're not doing, the last one's not moles to grams, it's actually moles to liters because we're talking about a gas at standard temperature and pressure. But we have to convert to moles first, so we have to do grams of A to moles of A if we want to use stoichiometry, if we want to be able to convert from one thing to another. So we'll start off with the 12.0 grams of calcium carbonate, and we're going to convert to moles. So that means we need the molar mass for calcium carbonate. So just kind of reviewing again, looking over at our periodic table, molar mass. So we get the molar mass for calcium. That's, let me write the formula there. So 1 calcium, so 40.08. And then the molar mass of carbon, 12.01. And since there's 3 oxygens, you'd also have 3 times 16. And when I did that earlier, I got 100.09. And that the units are there, grams per mole, as always. But that's the molar mass you're going to use. So 100.09 grams of calcium carbonate per 1 mole of calcium carbonate. Next up, we're going to want to go from moles of A to moles of B. So we're going to go from moles of calcium carbonate, and they were asking for carbon dioxide gas. So we're going to go to moles of CO2. And from the balanced chemical equation, recall what we were saying earlier, it's all a 1-to-1 ratio, so it was already balanced. So for every 1 mole of calcium carbonate that reacts, we create 1 mole of CO2. So this is just a 1-to-1 mole ratio. It's very important for writing that, even though it seems kind of trivial because it's just a 1-to-1 ratio. It's really important to write that just to show your units canceling. So grams of calcium carbonate canceled, and then moles of calcium carbonate canceled. And then in the last conversion, we're going to have the molar, or no, sorry, no, we're not, because we're going to liters. That's what we were talking about earlier. If we were going to grams of CO2, which we kind of will be doing in the last one because they're asking for grams of calcium carbonate. Thought I had another one. Then we'd use the molar mass. But since it's a gas, going from moles to liters, we're going to use this conversion over here. Now, since we want liters, we want the liters on top. And since we need to cancel moles, we'll put moles on bottom. And it's 22.4 liters per 1 mole. So moles of CO2 is going to cancel. So on your calculator, you have 12 divided by 100.09. That's just 1 times 22.4. And when I did it, my calculator told me, I'm kind of running out of room to write, so I'll just write it down here. My calculator said 2.686, which we would want to round to 3 sig figs because that 12.0, that has 3 sig figs, so I'll round this to 2.69, and then the units are liters of CO2. Okay, for the last one on this page, it says how many grams of calcium carbonate will be consumed if 500 grams of sulfuric acid react with the calcium carbonate in the statue. Okay, so we're starting off with this 500 grams of sulfuric acid, and we need to convert to grams of calcium carbonate. So 500 grams of sulfuric acid, that's the H2SO4. And since we're starting with grams of one thing and converting to grams of another, our general strategy, similar to before, we'll have grams of substance A, converting to moles of substance A using the molar mass, converting to moles of substance B using the mole to mole ratio, converting to grams of substance B using its molar mass. So we'll have 3 conversions. First up, we want to go from grams of sulfuric acid to moles of sulfuric acid. Then we're going to go from moles of sulfuric acid to moles of calcium carbonate. And then we'll go from moles of calcium carbonate to grams of calcium carbonate. So just paying attention to our units, grams of H2SO4 will cancel with the first conversion, then moles of H2SO4 will cancel with the second conversion, and then moles of calcium carbonate with the third one. Now, I haven't written the actual numbers in, but that's our setup, that's our strategy. I'm just showing that the units are going to cancel as we expect. So now we'll fill in numbers. So H2SO4, the molar mass. So you need hydrogen, and there's 2 of them. And then we want the molar mass for sulfur, 32.06, and there's 1. And then there's 4 oxygens in that formula, so 4 times 16. And when I did that, I got a molar mass of 98.07. 98.07 grams per 1 mole. So then in the second one, that's the mole to mole ratio. So you always look back at the balanced chemical equation. And we're trying to go from sulfuric acid to calcium carbonate. So again, that was a 1-to-1 mole ratio. For every 1 mole of sulfuric acid that reacts, 1 mole of calcium carbonate is also going to react. So we'll have a 1 and a 1 right here. They're not always going to be 1-to-1. With our reaction, it just happened to be already balanced 1 mole of everything. But you always need to look back at your balanced chemical equation. And then molar mass of calcium carbonate, so we had that in an earlier part, so 100.09 grams per 1 mole. So again, that's our setup, and we expect 4 sig figs this time. So because the 500.0, that has 4 sig figs, we're going to make sure we do this one up to 4 sig figs. So we'll do 500 divided by 98.07 times 100.09. So that's what you do in your calculator. And my calculator told me 510.23. So I'll round that to 510.2. And the units are grams of calcium carbonate.